Hawk-Vogel's behavior fits a pattern seen across the Alps. In recent decades, extreme weather has become more frequent. Intense rain, hotter summers, and volatile storms. Lightning is under investigation too. Repeated electrical strikes can micro-damage rock, and when you combine that with prolonged saturation from rain, the structural integrity of fractured dolomite can degrade over time. It's death by 1,000 cuts. No single factor explains it, but together they tip the balance. Monitoring continues around the clock. Millimeters matter here. A slight jump in displacement speed can separate, stable enough for now, from failure in progress. And the hazard isn't only rockfall. Should a large collapse occur, secondary debris or mud flows could mobilize later, potentially traveling into the Hinterbach Valley and creating follow-on dangers. That's why planners are already sketching longer-term protections, not just emergency responses. Add it all up, climate trends, the natural fatigue of an old mountain, human exposure, and the slow arithmetic of geology. And Hawk-Vogel has become a working laboratory. It's no longer just a summit to photograph or bag. It's a case study in how fast solid ground can change. The old cliché, solid as a rock, doesn't land the way it used to when the rock is riddled with widening joints and measurable motion. What does feel solid is the need to respect both the landscape and the science watching over it. If stories like this catch your interest, stick around, subscribe, tap the bell so you don't miss new deep dives, and pass this along to friends who follow natural hazards. And tell us in the comments what you make of the Hawk-Vogel situation, or if you've seen similar slope instabilities on your own travels. Your experiences help widen the discussion. For those who want a little more technical context, consider the mechanics at play. Main dolomite typically features bedding parallel weaknesses and vertical fractures formed over geologic time. Freeze-thaw cycles widen those voids as water expands into ice, and in warmer seasons, infiltrating rain reduces friction along those same plains. Add the occasional seismic vibration, regional earthquakes, or even distant tremors can contribute. And you have a system primed for episodic movement. Each episode need not be catastrophic on its own, but cumulatively, they can reduce the safety margin until a nudge, an intense storm, a temperature swing, or a saturated week pushes the mass beyond its threshold. That is where monitoring earns its reputation. Laser scanners map the face repeatedly, comparing point clouds to detect subtle bulges or overhang growth. Geophones listen for microcracking, tiny acoustic emissions that hint at bonds failing within the rock mass. Crack meters measure aperture changes across the fissure, while GPS monuments track surface displacement. Feed all that into a living 3D model, and you can see which blocks are moving coherently and which are locked, giving responders a target for closures and evacuations that is grounded in data rather than guesswork. The goal is not to eliminate risk, no one can, but to convert uncertainty into informed decisions that save time and lives. The social piece matters too. Messaging must balance clarity and proportion, neither downplay nor sensationalize. Local guides, HUD operators, and municipal leaders succeed when communications are simple, timely, and consistent. Close today signs need clear detours. Alert levels should be color-coded and explained. Evacuation drills should be practiced in shoulder seasons when routes are less crowded. Small choices like multilingual notices or QR codes linking to live dashboards can save minutes when minutes matter. And visitors can help by treating closures as lines not to be crossed rather than challenges to brag about online. Finally, remember that mountains change on human timescales more often than we think. The Alps are not static museum pieces. They're dynamic landforms shaped by uplift, weathering, ice, water, and gravity. Hawk-Vogel is a reminder that beauty and hazard live side by side. Respect the forecasts, heed the ropes, and treat that widening crack not as a spectacle, but as a message from the rock itself. As we wrap up, a quick note on personal responsibility. If you visit this area, plan conservatively. Check current closures, register your route when required. Carry a map and headlamp even on fair weather days, and turn around early if the ground or the forecast feels wrong. The summit will be there tomorrow. Your margin for error may not. Sicily's towering fire mountain looms over the island's east like a restless cathedral. Mount Etna in southern Italy is not only large by European standards, it is the continent's most energetic volcano, a place where the crust moves and sometimes roars. Its summit stands near 10,825 feet, about 3,300 meters, though the exact number shifts with each outburst as craters build and collapse. For centuries, Etna has cycled through eruptions and pauses, becoming both a research site and a major attraction. That appeal comes with a sober reality. Beauty and danger share the same slope. Etna's behavior does not follow one simple script. It moves along a spectrum, from modest strombolian pops and ash puffs to short, intense episodes that fling columns of molten rock skyward. In the latest chapter, fresh lava has again threaded down the flanks, cutting glowing rivers through black scoria, while orange fountains light the night. Authorities tightened access, keeping people below roughly 8,200 feet, about 2,500 meters, while instruments flagged elevated shaking. The goal is straightforward: admire the show, but keep distance while the mountain's pulse is high. A new feature has become the focal point of concern, a visible fissure on the upper slope. Drone surveys and handheld footage make the crack unmistakable. This is not a surface blemish. Fractures like this reflect underground stress as pressurized magma pries rock apart. Such openings can precede larger events, lateral eruptions lower on the cone, or, in more severe cases, structural slumps that peel away portions of the flank. Scientists have long measured a slow, persistent slide of parts of Etna seaward, a creep that usually proceeds at a walking pace each year, but hints at the forces at work inside the edifice. In rare cases elsewhere, sudden volcanic slope failures have even kicked up waves. That is not a forecast for Sicily, but it explains why a new crack instantly raises the stakes for monitoring. Even as lava fountains and glowing streams seize the eye, the volcano's internal heartbeat, the tremor signal, continues. It strengthens and dips, but together with surface deformation, it points to a system under pressure. Volcanologists are asking a simple question with complicated implications. Is this a familiar pulse in Etna's rhythm, or the start of a deeper reshaping of the mountain's plumbing and flanks? The fracture sits just below the summit crater complex, in what specialists call a subterminal zone, near the 3,000-meter contour. That belt is notorious among Etna watchers, because stress can accumulate there until the volcano chooses a side vent instead of the summit. Flank eruptions are disruptive. They can open abruptly, cross trails and roads, and send lava toward valleys long unused to flows. Their unpredictability raises risk for hikers, workers, and nearby communities alike. Ground sensors show deformation consistent with magma intrusion, hot material wedging into cracks and lifting the surface. Bi-amount satellites detect even when people notice nothing. The new fissure is likely the surface expression of that push. If intrusion continues, modest activity can escalate into stronger paroxysms, or if rock fails, into local collapses. Recent aerial passes mapped several small vents feeding multiple lava tongues. As they descended, the flows split and rejoined like braids in a river. The farthest fronts reached about 7,546 feet, around 2,300 meters. Higher up, the summit vents above, roughly 9,843 feet, near 3,000 meters, continued to supply fresh magma, turning the upper slopes into a moving assembly line of incandescent rock. In parallel, Italian civil protection raised the alert posture. An F1 advisory signals heightened caution and keeps the summit effectively off-limits. Should conditions escalate to an F2 stance, as happened earlier this season, authorities would warn about fast-moving hot clouds and sudden hazards. A recent dip in seismic chatter may look like relief, but lulls on Etna often precede bursts. Paroxysmal episodes, sudden violent releases of pressure, can drive sky-high lava jets, loft tall ash plumes, and blast glowing clasts across wide arcs. Those clasts, called lapilli volcanic bombs, can be as small as gravel or as large as a football, and they travel fast. On busy volcanoes worldwide, people have been injured by projectiles and ash clouds that outran expectations. A grim lesson from New Zealand's Wakari/White Island is that a volcano in routine activity can still switch gears without much warning. Etna is more active than most, so that lesson applies doubly here. Part of the management challenge is Etna's shape-shifting tempo. A cycle can start with tame spattering, leap into fountains, toss short-lived pyroclastic surges, then fall back to a simmer. The newly mapped fracture could mark a deviation from that familiar arc, hinting that structural stress is accumulating in a way that increases the odds of a lateral opening. Italy's National Institute of Geophysics and Volcanology reports ongoing strombolian bursts at the summit with intermittent ash visible from surrounding towns. Analysts watch more than camera images. They track the precise height of advancing lava fronts, monitor the rise and fall of harmonic tremor, and listen for infrasound signatures that reveal explosions even when weather hides the vents. Together, those metrics show magma still moving underground and feeding the surface. Because the system is unsettled, caution is wise. No one can say with confidence how the next day or two will unfold, and that uncertainty is itself a warning sign. Persistent tremor, active deformation, a fresh fissure, and multiple lava sources argue for restraint on the mountain and vigilance in the communities below. A new vent can open with little notice. An existing vent can choke and then clear with more force. Wind can swing an ash plume over a road that was clear an hour earlier. Sicilians have lived with that reality for generations. Ash on the windshield at breakfast and a faint glow on the horizon after sunset are part of the local rhythm. When instruments show rising risk, authorities close trails and restrict access. The latest fracture, together with pressure signals, argues for a stretch of heightened respect. Being prepared, knowing routes, keeping masks, having a communication plan is not alarmist. It is responsible. Round-the-clock monitoring continues. Networks of seismometers listen for swarms, too small for people to feel. GPS receivers and tilt meters register millimeter-scale motions of the ground. Thermal cameras chart the heat of flows and vents. Gas sensors measure sulfur dioxide and other emissions that rise when new magma nears the surface. Drones supply overhead views that ground teams cannot get safely. Together, these tools give a near real-time portrait of Etna's mood and help officials adjust closures and guidance. The broader scientific community follows closely because each Etna cycle teaches lessons that travel. Comparing data from Sicily with other regions sharpens models of magma ascent, flank stability, and the thresholds that tip a photogenic eruption into a hazardous one. In that sense, every measurement taken on Etna contributes to the global understanding of how our planet moves heat and material from its depths to the surface. For visitors and locals, the advice remains simple. Enjoy the spectacle from safe lookouts and respect guidance from the park and civil protection. Keep clear of summit zones. While the alert is elevated, the mountain's beauty is real, and so is its unpredictability. Respecting both is how you witness the show, without becoming part of the response. If you're passionate about geology and want more updates as this sequence evolves, stay tuned. We'll keep translating measurements and field notes into plain language. Share your thoughts below. Do you think this fissure signals a larger shift, or will Etna settle back into its familiar cadence? Your perspective helps guide what we explain next, and your caution helps keep everyone safe on the slopes. Quick glossary. Strombolian means rhythmic bursts from gas bubbles at the vent, spectacular but typically limited in range. A paroxysm is a short, powerful peak that can hurl lava high and spread ash widely. Pyroclastic flows are fast, ground-hugging clouds of hot gas, ash, and rock. Rare on Etna, but dangerous enough to drive higher alerts. Lapilli are small cinders. Volcanic bombs are larger blobs that harden in flight. Terms like these explain why rules can change quickly. Last point, volcano science is probabilistic, not prophetic. Analysts merge many weak signals, small gas shifts, subtle tremor, centimeters of tilt, into a picture of rising or falling risk, then revise it as new data arrive. Patience with restrictions and respect for the mountain make safer outcomes possible. Stay informed, stay flexible, and give Etna space.